Now this is question 6F from exercise 7B. I'm not going to do this exactly the order they ask us to do it for, but they do ask us to find the vertex and find if it's a maximum or minimum, and also check by completing the square. I'm actually going to do the complete the square part first, so I want to rewrite all this. First of all, I don't like the order this is written in. So just using the commutative rule, I'm going to change the order. And also, when I'm completing the square, I don't particularly like the negatives here, but I'm going to finish up with -4 as a factor. So I can probably get around that problem quite nicely here. Now I'm only going to take a factor on the first two terms here. So -4, I already have -4 here, so this is just going to be positive x. And then now I'm going to do the completing of the square part. So I'm going to do half the coefficient of, this is 1x, so half of 1 is 1/2. Now when I square this, 1/2 squared is 1/4, times by -4 is -1, but I don't want -1 now, I want +1, so what I actually need to do here is I need to add on 2. So what that means for my vertex is doing the opposite here, and then this one's good. That would be my vertex, and just remember that the -4, the 4 tells you the steepness, and the negative tells you it's upside down, so this is an upside down U, so that would also tell me that this is actually going to be a maximum as well. So that's really, I think, actually the last part of the question. Also, it says state the range of values the functions can take. Well, if this is the highest value I can have, the highest y value, remember range is y values, the maximum value is 2, then my range must be less than or equal to 2. Obviously, I can have equal to 2 because that's actually the vertex for that part. Now, going back and doing this by calculus. So this is the y equals. So if I differentiate this, so dy by dx, differential of -4x is -4, and differential of -4x squared, bring the 2 to the front, so I get -8x. And I'm just going to switch the order around there to make this a little bit easier. And this is the line I want to see, so you can tell the examiner what you're doing. Maximums and minimums at dy by dx equals 0. So in other words, this equation equals 0. And then we're just going to solve this equation. So bring the -4 to the other side. And then divide both sides by -8. So 4 over -8, well 4/8 is 1/2, and a positive divided by a negative is a negative. So we've got x equals -1/2, which is what we had over here as well, so that's good to know that we've got the right answer for that part. To find the y value, we're going to need to plug back into this formula up here. So we've got 1 minus 4 times -1/2 minus 4 times -1/2 squared. I'm just going to be very careful with all these negative signs here. 2 negatives here are going to make a plus. 4 times 1/2 is 2. -1/4 squared, order of operations, is +1/4. Times by -4 is -1. So that equals 2, which is also what we found over here. Now to find if it is a maximum or minimum, we're going to do the second derivative. So in other words, we're going to differentiate this expression. So derivative of that is going to be -8. And derivative of -4 is just 0, so that's my derivative. As this is just a number, we can say straight away this is less than 0. And therefore, that means that this is a maximum at the point that we found, which was -1/2, 2. Just to check, we can see that that is indeed the same answer. So number's not quite so nice on this question, but the principle's exactly the same. And for now, I'm going to say this we could use completing the square. We're going to use this method for when we get to questions where it's cubic or above, and then completing the square won't actually work.